Vibration Analysis Introduction. Excited frequencies, natural frequencies, are a property of the system. Amplified vibration, called resonance, occurs when a generated frequency is tuned to a natural frequency. Natural frequencies are often referred to as a single frequency. Vibration is amplified in a band of frequencies around the natural frequency, as in Figure 1. The amplitude of the vibration in this band depends on the damping. When we refer to the natural frequency, we often mean the center frequency. Natural frequencies can be excited by harmonic motion if the harmonic motion is within the half-power points of the center frequency and contains enough energy. The half-power points are down 3 decibels on either side of the center frequency. The frequency range between these half-power points is called the bandwidth of the natural frequency. The half-power point, or 3 decibels, is 0.707 times peak at the center frequency. It is a general rule to stay at least 10% away from each side of the center frequency. If some frequency is within the bandwidth of the natural frequency, and this frequency contains enough energy to excite the natural frequency, the natural frequency will be present. The term critical speed means the rotating speed of the unit equals the natural frequency. When this occurs, the natural frequency is considered unacceptable by some experts. Damping is the measure of a machine's ability to absorb energy. Therefore, a relatively undamped vibration signal can be high in amplitude and relatively narrow-banded. A relatively damped signal can be low in amplitude and relatively wide-banded. Figure 1 displays a relatively damped frequency. Fc is the center frequency and is equal to 18 Hz. F1 is the low frequency at the half-power point, 0.707 times peak, and is equal to 14 Hz. F2 is the high frequency at the half-power point and is equal to 22 Hz. From this information, an amplification factor, AF, can be calculated. Amplification factor equals to center frequency divided by F1 minus F2 equals to 18 divided by 22 minus 14 equals to 18 divided by 8. Or amplification factor equals to 2.25. Some experts agree that the amplification factor should be less than 8. Note that the result is the same if RPM is substituted for Hertz. Some standards for fluid film-bearing machines require an amplification factor of less than 8. However, for rolling element bearings, it is hard to get less than 12. Natural frequencies can be helpful when they act as a carrier, transporting the source of excitation to the measurement point. This normally occurs when natural frequencies are excited by periodic motion such as hits, bumps, or impacts. In such cases, the natural frequency can be present with spectral lines on each side. The number of these spectral lines, or sidebands, is determined by damping and distortion of the waveform. The difference frequency between the spectral lines identifies the frequency or source of excitation. More than one natural frequency may be present, and harmonics of the natural frequencies can occur if distortion is present.